Here we want to solve this rational equation. And so what we're going to do in this case is eliminate the fractions. The way we'll do that is to multiply through the entire equation by the least common denominator. In this case, we have a factor of x, a factor of 3, and a factor of 6. Well, 6 contains a factor of 3, so there's just an additional factor of 2. So a 6 and an x would satisfy all of these denominators. So what we're going to do is multiply through our entire equation on both sides by 6x. So we'll have 6x over 1 times 5 over x plus 6x over 1 times 2/3 equals 6x over 1 times 2 minus 6x over 1 times 2 over x, and then minus 6x over 1 times 1/6. Here the x's cancel, leaving 6 times 5, which is 30. Here the 3 cancels, leaving a 2x times 2, which is 4x. Then we have a 6x times 2 is 12x. The x's cancel, leaving a minus 6 times 2 is minus 12. And finally, the 6's cancel, leaving a minus x. Simplifying this now, we have 30 plus 4x, and on the right we can subtract 1x to have 11x minus 12. I'm going to subtract 4x from both sides to get all the x's on the right, and I'm left with 30 equals 7x minus 12. Adding 12, I get 42 equals 7x. Finally, dividing by 7, I get x equals 6. But one thing I always have to verify when I'm solving rational expressions is this may be a solution or it may be an undefined point. The way I check to make sure this is indeed the solution is to make sure that it does not make any of my denominators 0. And it doesn't, therefore 6 is the solution. And I could also substitute it into check to make sure that it makes my equation true.